The next one we're going to talk about is a pie graph. Like we mentioned earlier, a pie graph shows parts of a whole. So we can represent this as a percentage or a fraction. And each piece is proportional to its numerical value. So what does that mean? So again, if you have one whole and it's percentage, that means that the total is going to be 100%. So let's say we had this, which is college majors. So this shows us at like one college, for instance, that in orange, there's a STEM field. So 25% or 1/4 of the kids are majoring in something STEM related, STEM being science, technology, engineering, or math. Then we have this light blue color, which is business management. This is at 21%. 21% is a little more than 1/5, but it's a little bigger than 1/5. It's not exactly 1/5. Then we have in yellow, 14% is political science. Then we have in blue communications, which is 8%. Multidisciplinary or humanities, so this might be like liberal arts, is 29%. So this is actually closer to 1/3. So a lot more people. And just graphically, you can see the red mark is a lot bigger than the other portion. So that's what we mean by each piece is proportional to its value. Then we have 3% as no response. So they did not respond to the survey. So again, this shows us out of one whole, or one whole, in this case, university, what did people say? Another example, again, could be numerical data as long as it's still based on one whole. So if this was our class, and these were all the student grades. So again, our class is going to be what we call the one whole. And then each of the students are the parts or pieces. And again, it's proportional to how many students are in that group. So this shows us that if 4 students got an A, this would be about 14%, and this is how much it would look like, an A. Then if we had a B, 12 students got a B, that's 42.9%. That's a lot bigger, right? Again, our portion is a lot bigger. Then C, 10 students scored a C, and that was 35%. And then 2 students scored a D, which is about 7%. So I can tell that our class is equal to 4 plus 12 plus 10 plus 2. So that means we have 12 plus 12 is 24 plus 4. So this means 28 students are in this class. The next one we're going to talk about is a stem and leaf plot. And I'm sure you haven't heard of this before, but it's pretty easy once you learn the system. So each data point is broken down into a stem and a leaf. And typically it will say stem and leaf, but if it doesn't, just know that the first number is the stem, the second is the leaf. The stem includes all but the last digit. All but the last digit. And the leaf of the number will always be the last digit. So what this is saying is that in this data right here, we have the numbers 56 and 58. Again, the last digit is put in the leaf. You can think about the word leaf starts with an L, so that's the last digit starting with an L. And then everything that's not the last digit is part of the stem. So again, for this one right here, we have 61, 62, 62. So 2 people, let's say this was scores on a test, 2 people scored 62. Then we have 64, then we have 68. Let's look at one that looks a little more complicated. Again, here the stem is 10 and the leaf is 0, which means that someone scored a 100. But that means only one person scored 100. We look here, these are the B's. Someone scored a 90 because you take the stem and the leaf. Someone scored a 92, again, stem and leaf. And someone scored a 96. So 3 people scored in the 90s. So that's how it works. The leaf tells us how many data points there are. So if we kept doing this and we did all the different numbers, again, if we counted all the leaves up, all these numbers, that tells us how many students are in this data set, how many people responded. So again, how many data points there are, you just count the number of numbers in the leaf. Again, you don't count, you see here there are 5 sixes, that's not one person, right? That means that 5 people scored 86. 5 people scored 86. Because the stem is 8 and there were 5 leaves that were the number 6.